up, you guys? So in this one, earthquake, we're going to be talking about writing rational functions. I'm not really sure why they're calling it this, but this is what the section is called. Biggest thing you guys need to remember is that a rational function has a variable in the denominator. So a rational function looks like this, right? It could be any of that. A rational function could also look like this. A rational function probably doesn't look like, like this. Party time. Okay? Good girl, Corey. Thank you for letting me use you. I just freaked out. Alright, yeah, continue to sneeze. Fool. She's mad at me now. Alright. But what we're going to talk about, most importantly, we talked about this some. It's called our reciprocal function, or our rational function. But this is just our parent function, 1 over x. Two things. One thing, it is undefined when x equals 0. So since it is undefined when x equals 0, because remember we can't divide by 0, it's not possible, what we have there is called a vertical asymptote. All right. So now, if I create a table of values, x and y, let's make a big one. All right, so if I put in -10, -9, -8, -7, you get the point. Let me finish this out real quick. All right, so if I plug in these values to 1 over x, this would be -1 over 10, right? 1 over -9 would be -1 ninth. -1 over 8, so on and so forth. All right, let me take a second and I'll fill these out. All right, so here's all of our values. 1 over our number. Remember, 1 over 0 is undefined, so that creates something called a vertical asymptote. A-S-Y, I missed the S. A-S-Y-M-P-T-O-T-E. Asymptote. No, I'm just kidding. It's asymptote. So that's undefined. And then 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. So they're different values, but notice they're getting really, really, really small. So if I were to graph these values, 1 over 1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, 1/10, right? I can't even really depict it on my graph. But as I were to graph it, it would continue to get closer and closer and closer to 0. Right? It's getting really, 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 really small there. It'll do the same thing in the negative direction, right? It was -1, -1/2, -1/3, -1/4, -1/5, 1/6, 1/7, 1/8, 1/9, 1/10. So it's getting really, really close to 0 in that direction as well. So it will also never reach 0. So since it never reaches that value, this is called a horizontal asymptote. We have a horizontal asymptote, at y equals 0. So the y values are approaching 0, but they're never actually going to touch 0. So now we kind of have this blank space where we're getting closer and closer to our asymptote in this direction. So here's what I'll do for you guys. I'm going to make some more x and y values. And I'm going to make them fractions, right? Because we're like between 0 and 1, and we're between 0 and -1. But let's just look between 0 and 1 and see what happens. So say I have like an x value of 1/5. Say I have 1/10. Say I have 1/2. I probably should have done that first. That's all right. 1/4. 1 over 99. So this is really, 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 really close to when x is 0, but it's not actually there. So I'm getting close to my undefined value, but I'm not actually on it yet. So remember, when we were dividing fractions, right, I have 1 divided by 1/5. I was flipping the second and multiplying, right? So 1 times 5 over 1, which would just be 5. Same sort of deal here. That'll be 10, that'll be 2, 4, and 99. So that's a really big y value. So as it gets super close to x equals 0, it becomes increasingly large in the y direction. So the other part of our graph here is I was at 1/2, 2, 1/3, 3, 1/4, 4, 1/5 5, 1/6 6, 1/7 7, 1/8 8, 1/9 9, 1/10 10. So it is getting really super close to x equals 0, but it doesn't ever actually touch it. So that's how it's getting closer there. It does the same thing in the x direction, or sorry, as it approaches 0 from the other side, except since we have like -1/2, it would be at -2. -1/3 would be at -3, -1/4 would be at -4, so on and so forth. So that would be our graph of our reciprocal function, or our rational function. Either way that you call it means the same thing. All right, so essentially that's what they're going to be asking you about. So notice the domain is everything except 0. The range is all of the y values except 0, so we can go up forever, and we get really close to 0, but we don't ever actually touch it. I think that's all they're going to ask you about. Again, if you guys have questions, please just let me know. I'll answer your emails all the time. So another thing they're going to ask you about is if we have inverse variation, what happens if we double the input? So remember, inverse variation, this was in the last video, y equals k over x. So this number is my input, this number is my output. So remember as well, inverse variation, as something gets bigger, the other thing gets smaller. So if I am doubling my input, double input, that leads to one thing's getting bigger, so the output must get smaller. So that would be 1/2 of the output. By the same factor, you do 1 over. So let's see, what happens when the input is divided by 5 or by 6? So if we do 1/5 of the input, the output becomes larger by a factor of 5. Likewise, if we do 1/6, it becomes larger times 6. So it does the opposite thing. It's called inverse variation because you're taking the inverse of the number, the reciprocal of the number. All right, that's really all that we got for you guys in this video. A lot of it was just review from stuff we've done before. So please let me know what questions you guys have as you go through this stuff. All right, I'll talk to you all soon. Bye.